Hello and welcome to another video for Calculus 1. In this video, we are going to discuss about antiderivatives. So a function uppercase f of x is an antiderivative of another function lowercase f of x on an open interval ab if the derivative of f of x equals the lowercase f of x for all x in ab. Or in another word, a function f of x is the antiderivative of f of x. If we find the derivative of this one, we get this other function. Okay, so for example, here this should be uppercase f. So f of x equals negative cosine x is an antiderivative of f of x equals sine of x because the derivative of negative cosine x equals sine x. Similarly, f of x equals 1/5 x to the fifth is an antiderivative of f of x equals x to the fourth because the derivative of this function equals x to the fourth. Okay, so antiderivative means just the opposite of derivative. So when you're finding antiderivative, we just have to go backward in a backward process, okay, or in the reverse order. So there's a theorem, which is the general antiderivative. So let f of x be an antiderivative of f of x on AB, then every other antiderivative on AB is of the form f of x plus c for some constant c. This is what it means, okay? So for example, if we take a function, let's say x to the fourth plus 5, and then if we find the derivative of this function, we get 4x cubed. And then if we take another function and let's say x to the fourth plus 7, if we find the derivative, then we get 4x cubed. Or if I take a function x to the fourth without any constant here, then I'm going to get 4x cubed. Now, if we are asked to find the antiderivative of 4x cubed, then this is also possible antiderivative. This is also possible antiderivative. This is also possible, and there could be infinitely many antiderivative of this function because we are getting this constant. When we find the derivative, the constant of derivative, the derivative of the constant is 0. So because of that, we could have a family of antiderivative. That's why, in general, if we are asked to find the antiderivative of 4x cubed, we write the antiderivative of 4x cubed is x to the fourth plus c, which means a constant. So it depends on which function we are talking about. It could be x to the fourth plus 5. Here the constant is 5. Here the constant is 7. In this case, the constant is 0. So this constant could be anything, any constant. Okay, so in general, that's why it's called general antiderivative. So the general antiderivative of any function, okay, f of x is the uppercase f of x plus this constant. So we find the derivative and then we find the antiderivative and then we add this constant with the antiderivative. So that is called the general antiderivative, or we also call it the family of antiderivative. Now let's use the concept of derivative here to find the antiderivative of these functions, okay? So first we know that, so let's look at the first example here. We know that the derivative of sine x is cosine x, which means, or this implies, antiderivative of cosine x is sine x. Or in more general, we'll write the antiderivative of cosine x, let's denote that by f of x, equals sine x and then plus c. Okay, so we write that constant. So similarly here, we know that that the derivative of x to the fifth equals 5x to the fourth, which means the antiderivative of 5x to the fourth is x to the fifth. Okay, or in more general, we write f of x equals x to the fifth plus c. That's the general antiderivative. Now the notation for antiderivative is, so when you're finding the antiderivative of a function, we write this symbol, which is called the integral symbol or indefinite integral. So the antiderivative of f of x is represented by the integral f of x dx, and that is uppercase f of x plus c. Or let's go back to the example that we did here. So for example, you're finding the antiderivative of cosine x. So this is how we write it in notation. Okay, so we write integral of cosine x dx equals sine x plus c. Similarly here, the integral of 5x to the fourth dx equals x to the fifth plus c. So this is how we write it in notation. So another name for antiderivative is indefinite integral. We can also call it indefinite integral. Now there's a rule. So we basically what we did in these examples is we just look at the derivative of function, and then we figure out the antiderivative. But that's sometimes when we look at the larger polynomial function, or when we look at the other different types of function, that's always not a good idea, not a good way to find the antiderivative. So we need to have some rules. That's what we are going to look at. So the first one is the power rule. So when we are finding derivative, if you remember, the power rule for the derivative is d over dx, x to the n is n x to the n minus 1. That's what we used to do. Now the power rule for antiderivative or the integral is the integral of x to the nth dx is x to the n plus 1 over n plus 1 plus c. So in order to prove this is an easy and quick proof. What we need to do is we need to find the derivative of this function, and that must be equal to this one. Remember, so f prime of x must be f of x. So that's what we are going to show. Okay, so let's go ahead and prove this. So to prove this, what we are going to do is we can just prove that the derivative of right hand side is x to the n such that n is not equals to -1. Okay, so let's go ahead and do that. So let's go ahead and find the derivative of the right hand side, which is x to the n plus 1 divided by n plus 1 plus c equals, now the derivative of x to the n plus 1 is n plus 1 times x to the n. Remember, the derivative is we subtract the exponent by 1, so we have n plus 1 minus 1 is just n, and then we already have n plus 1 in the denominator, plus derivative of this constant is 0. And that gives us, so n plus 1 and n plus 1 cancels out, so we get x to the n, which is the left-hand side of that equation out there. So that means, therefore, we can write the integral of x to the n dx equals x to the n plus 1 over n plus 1 plus c, where n cannot be -1. So just a quick example. Let me just give you one example here. So if we are finding the antiderivative or integral of x to the, let's say, 5 f dx, okay, so then that is x to the, so n plus 1 means 5 plus 1, which is 6, divided by n plus 1, which means 6, and then plus 1, sorry, plus c, Okay, so that is same as 1/6 x to the 6 plus c. That's how we find the antiderivative. So let's look at some examples. Or before example, so it is similar to the derivative. So if you have a constant multiple, we can pull out that constant multiple and find the integral, same as in derivative. Or if we are finding the integral or antiderivative of sum of two functions, then we can find the antiderivative of individual function and then add them. So this is same rule that we used for derivative. Now let's look at the first example. So this equals, so we can pull that constant out. So 3 times integral of x to the fourth dx minus 5 times integral of x to the 2/3 dx plus integral of x to the negative 3 dx. And then for that one, we get, so we have that constant times. So integral of x to the fourth is x to the 4 plus 1, which is 5, divided by 4 plus 1, which is 5. Minus 5x to the, we have 2/3, so 2/3 plus 1 is 5/3 divided by 5/3 plus, so x to the negative 3 plus 1 is x to the negative 2 divided by negative 2 plus, don't forget that c, we have a constant. So now let's clean this up. So we can write 3/5 x to the 5 plus, so if you simplify, if you divide 5 by 5 over 3, so we just get 3, sorry, this is minus 3 x to the 5/3. Then we have minus, so we can make this positive by writing it as 1 over, and we have that 2, so x is squared, then plus c. So this is the antiderivative of the given function. So for this one, we have a quotient here. We don't have any quotient rule now. So what we are going to do here is we are going to split this fraction. Okay, so this I'm going to write it down. So integral 4x to the fourth over x dx minus integral 6x squared over x dx. Now we can pull that constant out. And then we have x to the fourth divided by x is x cubed dx. And then minus, we can pull that 6 out. So x squared divided by x is x dx. And then we get 4 times, now the integral of x cubed is x to the fourth over 4 minus 6 times x squared over 2, because this is x to the 1. So when you add 1, it is 2. And then we add that constant for integral. Okay, so now this becomes 4 and 4 cancels out. So we have x to the fourth minus 6 over 2 is 3 x squared and plus c. So now these are some of the formulas are basic integrals. So it is just the opposite of the derivative. So the integral of x to the n is this one. The derivative of this function is x to the n. Similarly, the derivative of natural log of x, we already know that is 1 over x. That means the integral of 1 over x is natural log of x plus c. Okay, similarly, so we have all these functions like trig functions. So the derivative of sine x is cosine x. So the integral of cosine is sine. So we have all this formula here. So we have to remember these formulas. Okay. So next we are going to see a couple of examples using this integral. So make sure you remember these integrals. Okay, basic integrals. So now let's go ahead and look at this example here, the first one. So again, we can rewrite this as, so we have that constant, so we can pull that 5 out. So we have 5 integral of 1 over x dx minus 3 integral of x to the negative 13 dx. Then 5 times, so the integral of, if you look at the table, so integral of 1 over x is natural log of absolute value of x. So that's what we are going to write next. So natural log of absolute value of x minus 3 times, so the integral of x to the negative 13 is x to the negative 13 plus 1, which is negative 12 divided by negative 12 plus c. Okay, and that becomes 5 natural log of x. So 3 over 12 is 1/4, and that's going to be positive. And then we can put this in the denominator and make it positive. So this is 1 over 4x to the 12 plus c. So this is the integral. Similarly, if we look at the formula, so the integral of sine ax is 1 over a cosine ax, and it is negative. So the derivative of cosine x is negative sine x, but the integral of sine ax is the opposite. So the integral of sine is negative, the derivative of cosine is negative. So we really have to be careful with this formula because this is very easy to get confused with the derivative. Okay, so now we are going to get, so this is 1 over a, which means, so let me separate this first. So let me write it as integral sine 7t dt minus 18 integral of cosine t dt. Now the integral of sine ax is 1 over negative 1 over cosine ax. So here it is negative 1/7 cosine 7t minus 18 times. So now the integral of cosine t is sine t. So it's not negative. The derivative is negative, but the integral is positive. So it's opposite. So sine t and then plus c. So that's all we have. Let's look at another example. So the integral of e to the ax dx, that integral is 1 over a e to the ax plus c. Okay, so that's what we are going to use here. So this is, we have that 9 constant e to the negative 10x dx, and that becomes 9 times 1 over negative 10 e to the negative 10x plus c. Okay, and then we can rewrite this as negative 9 over 10 e to the negative 10x plus c. Okay, so this one we can factor that 6 out, and this is the inverse trig function. Okay, so if you go back here, let's look at the formula. So here, sine inverse x over a. So the integral of 1 over a squared minus x squared is the inverse sine x over a plus c. So this that question has this form. So what we are going to write here is, we are going to rewrite this as, so pull that 6 out, then we have 1 over square root of, instead of writing 36, so you can write 6 squared minus t squared dt. So we can use this formula now. 1 over square root of a squared minus x squared dx is the sine inverse x over a. Okay, so that's what we are going to use. Okay, so this one is 6, then the inverse of sine t over 6 plus c. Let's look at another example. So let's go ahead and rewrite this. So this is 5 integral of x squared dx plus integral of secant squared 4x dx. So we know that the derivative of tangent x is secant square x. That means the integral of secant square x is tangent x. But we have this form. So integral of secant squared ax dx equals 1 over a tangent ax. Okay, so if you go back here, I'll show you the formula. So the integral of secant squared x right here. So 1 over a tangent ax plus c. Okay, so that's what we are going to do here. So this equals 5. So x to the third over 3 plus, now secant square 4x dx is 1/4 tangent 4x then plus c, or we can rewrite this as 5/3 x cubed plus 1 over 4 tangent 4x plus c. Now, those are some of the examples. We can do as many examples as we want, but that's all. Those are the examples for finding integral. Now, what we are going to look at is we are going to look at some initial value problems. So what this does is, remember, if when in every integral that we found, we have this constant of integral c. Okay, so this means this gives us the general antiderivative. Now, what we are going to do next here with the initial value problem is we are given an initial value or we are given a condition here. Based of that condition, we are going to find that constant that fits for this condition. Okay, so initial value problem, we are doing exact same thing. We are finding the integral, but we are going to find that constant, the missing, we used to use C for general antiderivative, but now we are going to find what that C is, the particular value for that C, okay? So basically, it is kind of like differential equation. Okay, so we have this derivative here. So our goal is to find the function. So we have to integrate, we have to do the opposite of derivative in order to get rid of that derivative. That means we are going to find the integral. So this is how we are going to solve this. Okay, so we have f prime of x equals 4x to the 7th. So our goal is to find the function f of x. That's what solving initial value problem is. So in order to get f of x, I have to get rid of that derivative, which means I have to find the integral, so that the doing opposite, okay, undoing what is already done. That's what going to give us the function. Okay, so if I take the integral on both sides, so if I do integral of f prime of x, so when I write the integral, I have to write the dx, then I do have to do the same thing on the other side. So basically, I'm just taking integral on both sides. Now the left hand side is just going to give me the function because we have that derivative. When I integrate, I get the function without derivative. Equals, here we have 4. Now the integral of x to the 7th is x to the 8th. Sorry, this is x to the 8th over 8 plus c. Or basically what we have is f of x equals 1 half x to the 8th plus c. So I got my general antiderivative. Now what we are going to do is we are going to use this initial value and we are going to figure out what that c is. Now what is this saying? This is how we are going to read. So f of 0 equals 4 means when x is 0, the value of the function is 4, or f of x is 4 when x is 0. So basically this is what we are going to do here. So this is this f of x is 4 when x is 0. Now that gives us c equals 4. So therefore, we have f of x equals 1 half x to the 8th plus 4 because the value of c is 4. So this is the particular function that we are looking based on that given condition. Now let's look at another example here. It's the same thing. We are given the derivative, so we are going to find the function. So basically, we are going to integrate on both sides. So integral of f prime of t dt equals integral of sine pi times t dt. So when we integrate, we get f of t equals, so the integral of sine pi t, so pi is the constant, so it's negative 1 over pi cosine pi t plus c. Now what we are going to do is we are going to use this initial condition. So this says when t is 2, the value of the function is 2. So it means 2 equals negative 1 over pi cosine of, so t is 2 means 2 times pi is 2 pi plus c. Now we know that cosine 2 pi is same as cosine 0, which is 1. So 2 equals negative 1 over pi plus c. Or if we solve for c, we get c equals 2 plus 1 over pi. Therefore, our function is f of t equals, so this one, so negative 1 over pi cosine pi of t plus, so c, the value of c is 2 plus 1 over pi. And this is the solution to the initial value problem. Now let's look at an application. So this is, remember when we did the derivative, when we are given a position function, if we find the derivative, we got velocity. If we find the derivative of velocity, we got acceleration. Now we are going to do the opposite here, okay? So the question is, a vehicle is traveling with a velocity of 32 meters per second, and then it begins to slow down at time t equals 0. So when it begins to slow down, so that's the time that we are going to record as 0, with a constant deceleration of negative 8 meters per second. So there's the acceleration, negative acceleration, which means deceleration. Find the velocity at time t. So we're going to find the velocity function. So remember, acceleration is given by the derivative of velocity. Okay, so we can write that here. So for A, we know, okay, we know that the derivative of velocity gives us the acceleration. Okay, so now if we integrate on both sides, so integral b prime of t equals integral, sorry, let me do it here. I need more space, so I'm going to write here. Okay, so b prime of t equals a of t. Now if we integrate, so this implies b prime of t dt equals integral a of t dt. Now when we integrate b prime of t, we just get v of t equals integral. Now the acceleration is given negative 8 meters per second, so just write negative 8 dt. Now we get v of t equals, so the integral of negative 8 is negative 8t plus the constant. Now the initial value problem, this is kind of like initial value problem. Now if we look over here, it's at time t equals 0, at time t equals 0, the velocity is 32 meters per second. So which means we have v of 0 equals 32 meters per second. Okay, so that's what we are going to use here. So the velocity is 32 when time is 0 plus c, which gives us c equals 32, or this implies v of t, or the velocity function, is negative 8t plus c, which is plus 32. So this is the velocity function, or that is the velocity at time t. Okay, we got that velocity function. Now the second question is, we are asked to find the distance. So again, remember the derivative of position, or which is the distance function, or the position function, gives us the velocity. So for B, we know that the derivative of position, or the distance, gives us the velocity. Now if we integrate on both sides, so integrate that with respect to t, integrate this one with respect to t, gives us position function, sorry, the position function, which is s of t equals integral of, so the velocity function is negative 8t plus 32 dt. And now s of t equals, the integral of negative 8t is negative 8t squared over 2 plus 32t plus c. And then s of t equals negative 4t squared plus 32t plus c. Now in order to find that c, we have to use the initial value. So now the initial value here is, at t equals 0, we start counting the distance when t is 0. So at t equals 0, it hasn't covered any distance. That means we can say that as the distance at time t equals 0 is just 0. So using the initial value, this is 0 equals, when t is 0, this is 0, this is 0. So we just get c. Okay, that implies c equals 0, or our position function is negative 4t plus 32t plus 0, sorry, 4t squared. So that is the position function, or the that function gives us the distance. Now our question is find the distance traveled before the car comes to a stop. Now we need to know when does the car comes to a stop. So we need to know time, okay? How long does it travel before it comes to the stop? So in order to find that, we know that when the car stops, the velocity is zero. So if we use this velocity function, so the velocity is zero after what time? So that's what we need to find. And using that time, we can find the distance traveled. So if we do this, so if we take the velocity is zero, equals negative 8t plus 32. And then if we solve for t, we get t equals 4, which means the car is going to come to a stop after 4 seconds. That means the distance traveled in that 4 seconds is s of 4 equals negative 4 squared plus 32 times 4, which is s of 4 equals, so if you simplify that, you get 64, and the unit is meters. So the distance traveled by the car before it comes to a stop is 64 meters. We'll just do this much for this video. I'll see you again in the next video.